Can a reporter tell me what's the first thing you did with your data? Who's a reporter? What's the first thing you did? Yeah.
We arranged it to numerical order.
Numerical order. So 72, 75, 76, 76, 77, 78, 79, 81. Okay, numerical order, because then the middle makes sense. If I want quarters, how do I need to cut it first? Half, which was right here. The median, 76.5. In half, first quartile, 75.5. In half, next quartile, 78.5. So if I want the interquartile range, what is the spread in the middle half of my data? I would do third quartile minus first quartile, which is 78.5 minus 75.5. Interquartile range is 3, okay? So again, here's what this means. Half of my data, the middle half of my data, all these numbers right here, have a spread of 3 beats per minute, okay? Now, does that show like these things are kind of close or kind of far apart? I think 3 is pretty close, right? Especially beats per minute. Next, reporters. Less than quartile 1, how many values? 3, 2, 1? I got 2. Right here. Between 1 and the median? 2. They're right here. Between the median and third quartile? 2. And higher? 2. And why does it make sense that they're all 2? Because there are 8 data points and we're cutting it into fourths. Correct? That's the whole, we're cutting it into fourths. Cool? So to summarize, the interquartile range tells you how spread out the middle half of the data is. Right? 2 quartiles in the middle, interquartile. The median, how does the median divide the data? In half. So, if we have data, we have first quartile and third quartile. We've kind of already talked about how much data is in those 2 quartiles. So, half of it, well, that'd be the range. But how much data is in there? Half or 50%, right? It's 2 of the 4 quartiles. And it's the middle half, right? We're talking about middle, central. Excellent. We've got one more thing to do here, and this one's going to be, you touched it, I think, in 6th grade, which means there's a good chance we're rusty. It looks crazy. Mean absolute deviation sounds crazy. It's not crazy. It just sounds crazy. So I like to think of this. I'm a memorizer by heart. In like science class, I would always write like note cards once and never have to look at them. Like I took a whole calculus class where like I got A's and got everything right and I had no idea what I was doing. I could just do what the teacher did and remember what to do without understanding. No, it's not nice. I got an A and I have no idea what I did. I wasted a whole year of my life. So I should have like focused on concept like I'm going to encourage you to do. And when I get students to focus on concept, you guys do better on tests, on finals, and the map test. So trust the process even if you find comfort in memorizing, okay? So I think about mean absolute deviation as what it is. And what it is I say this. On average, how far away is data from the average? But you're like, why are you saying average so much? Well, that's what it is. So if we're going to find the MAD, or the mean absolute deviation, really what we're asking is, on average, how far away is the data from the average? So it's like saying, hey, this is the middle. On average, all my data is this far away from that. That is going to take us to the what to do. So you could memorize the next steps we're doing as do this, but if we start here, it makes those steps happen, and I'm going to walk you through the thought process, okay? So, I actually don't want this whole thing. I just want these numbers. Oops. All right. Let me see if I can just get these numbers. I'm going to get it. I'm going to cut. I'm going to give us just a plain whiteboard, and I'm going to paste. So, here's our data set, these numbers. And so the question I want to ask is, on average, how far away are these numbers from their average? What would be the first thing I would need to know to be able to answer that, do you think? Yeah, Greta. What's the average? So I can do that. I'm going to add them up. I like to start on this one. I'm going to start bottom up. So 12, 19, 25, 30, 37, 39, 40. So if I add them all up, I get 40. And there are 1, 2, 3, 4, 5, 6, 7, 8 data points. 40 divided by 8 means my average is 5. Okay, so again, the question is, on average, how far am I away from 5 now? 5 is my average, okay? So I only do like a T-chart. The one on here has multiple things. So I kind of just do something like this real quick. And so I start asking myself, how far away from 5 is 1? It's 4 away from 1. How far away from 5 is 2? How far away is 3? 4 is, 5 is, 6 is, 7 is, and 12 is 7. So now, okay. So I'm going to reframe this again. The question I'm asking is, on average, how far am I away from average? Well, I know how far away I'm from average, but I want to know that on average. So what am I going to do with these values? Find the average. So this is how far away I am. I want to know how far away my data is on average from my average. So I'm going to add these up. I got 7, 9, 10, 13, 20. Divided by how many pieces I had? 8. So that's 10 fourths. 5 halves. 2.5 is my mean absolute deviation. And what this number means is, with this data set, on average, all of my data, on average, is 2.5 away from the average. The average is 5. You see that? Do you see how I can use the definition to tell you what to do instead of memorizing, do this, then do this, then do this? Like, you could probably even do that for a quiz, maybe a test or something. But what's going to happen if 2 years you don't see that, you're going to say, what do I do? Where, if you say, on average, how far away am I from the average? You might be like, oh, so I need to find the average. Then I need to see how far away it is, and then on average, how far away is that? It like brings you to the things to do with understanding what's being asked, okay? Versus when I see this, do this. That's what I'm going to encourage us to do. It's the first time we've seen it, so do I expect us to all be second time, but it was in 6th grade. Do I expect us all to be experts? No. I'm going to put the previous slide back up for you while you work. Maybe not. Yeah, I will. You guys already have your data values on your whiteboards. If you don't, look at your neighbors. So, what I suggest when you're using this is, I don't really use this column at all. Really what I do is I get the average, and then I say how far away it is from the average. Okay? And then we're going to find the average of that. So the first step everybody's going to do when they get to the whiteboard with their group is find the mean or the average, right? Because that's what you're going to check your data against. Let's get going. So, that's good. Everybody good with the average being 76.75?
Yes.
So to get this, I added these all up and divided by 8. Hey, in the back there, please. So to get the 76.75, I add them all up, divided by 8. That means if I equaled them all out, they'd be 76.75. I don't use this column. I'm going to jump right to the last one and say how far away from the average was my data points. So this one was 4.75 away. This one was 1.75 away. This one is 4.25 away. This one is 0.75 away. This one is 0.75 away. This one's 0.25 away. This one is 2.25 away. And this one is 1.25 away. So all I've done so far, as I said, my average is 76.75. This is how far away they all are from the average. Remember, the question I'm answering, though, is on average, how far am I away from the average? So if I add all these up, what I get? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I add them all up, I get 16. How many pieces of data are there? So the 16 says, in total, I'm 16 away for these 8, divided by the 8, and I get a 2 for the mean absolute deviation. So what this means is this. On average, I'm only 2 away from the average. Do you see how that means the center is really close? All my data on average is only 2 away from the average. Yeah, George.
Why does it go to like 0.75 and like 0.20?
Well, it depends if it's above or below, right? So if I'm going to a number that's above, there's like a quarter left to get to the whole number, right? And if it's below, there's not. It's 75 cents to get down to the nearest whole. I said cents, it's not cents, 0.75. Yeah.
Well, we wrote the wrong numbers. Like the bottom one, we had 4.25, but I still got 2, and now I'm confused.
Maybe you made the same mistake 2 places to balance each other out. But to get this number right here, all I did was subtract, and it was the difference of from the average to the data point. Which again means on average, all the data is 2 away from the average, which is pretty close, right? For some variability of heart rates. So that's what I mean. On average, how far away is it from the average? That takes you to find the average. How far away from that is it? What's the average of that? When you forget it tonight, what can you do? If you forget it tonight. Yeah, I'm recording this right now, what I'm saying to you. Okay? You don't believe me?
What? No, I do.
On Canvas. I link it every night, so make sure you go check out the video. You can skip everything else and just skip to this too if you want to, okay? All right. Lesson summary, it's in your packet. Let's go.